So last video was about WPF and architecture at large. This one will be again about architecture at large and maybe about a Blazor application and technology using Telerik controls. So I have left off about here, saying that there are question marks on this diagram. There are question marks, no question about it. The WPF application has been more or less developed. This is a demo application, not much in terms of functionality, but it shows what it's supposed to show. So now let's go to the next question mark, namely this one. What this gonna be? So this new episode, among other things, will describe the practical application of what's known as a clean architecture. I had an article about clean architecture some time ago, and that article contained few interesting circular diagrams. Here's one of them. It shows that according to clean architecture, presentation has to depend on domain. So domain is the centerpiece of the whole architecture. We shall see how this works in reality. I decided to stay in spirit of circular diagrams and clean architecture and put a circle around my domain. Now, the satellite little objects that indicated the arrows indicated they relate or depend on domain are my applications. This one again was WPF presentation, and today we are talking about this one. It's going to be Blazor application. I have upgraded to Visual Studio, and now I have a whole set of funky themes, one of which I figured would be better than the black one for the video because it's more readable. And what do we see in this new version of Visual Studio? The solution remained the same. It's project management demo. And most of the components in that solutions also remain the same. We see, of course, core. We see domain, and we see WPF that was developed a couple of weeks ago. But in addition to that, we see Blazor Server. And interestingly enough, Blazor Server sits as a like a first class presentation application within the same solution. It uses the same core, the same domain, and it sits at the same level as we see the WPF application does. Let us start. Let us start them both. Let's see how they work. So now we're trying to start WPF application, and bingo, there it is. So this is the one that was developed last time, and it has a project grid which relates to tasks tree. In task tree has hierarchical, of course, structure because it's a tree, and the top task relates to requirement analysis project. And we have I created 5 subtasks. I didn't want to put elaborate names, but suffice to say that we have project, top level task, and 5 subtasks. Now, let's start the Blazor application. Let's see what it looks like. Here's the Blazor application, and it looks like functionally quite similar to the WPF one. It also has a drawer control. It has a set of projects which are exactly the same as this project. And it has, again, relationship. We select one of the projects and we see, again, exactly the same thing. We see top level task related to requirement analysis and 5 subtasks. All exactly the same. I will ask myself a silly question, kind of, and give the obvious answer. Why two presentation applications show exactly the same data and also look almost the same? Well, the answer is obvious. They are sitting on the same domain code. This code connects to SQL Server, brings up collections of entities, convert them into view model elements, and display them using two presentation technologies, Blazor and WPF. In my Blazor application, unlike the WPF, which uses Syncfusion control set, I'm using Telerik control set because I still have a Telerik license. Telerik control set looks better than Syncfusion, as I already mentioned in the previous clip. It also, interestingly enough, has the second drawer in this drawer control, which is called Gunt. So Gunt is a special type of control, as probably many people already know, and it displays exactly what I'm trying to display in general in this system, the project and the tasks related to that project. So here, since the tasks have start and end date, the Gunt control is nice enough to show us the starts and the ends of each tasks and the percentage completion in a graphical form. Now, the second thing that I'm utilizing the Telerik facilities for are the themes. So I didn't write a single line of CSS for this Telerik project. All I do is load the Telerik themes, and the themes that Telerik provides are quite rich. So right now we are at Bootstrap main. We can go to dark. We can go to Fluent main, which is meh. Okay, we can go to default main. I don't like the fonts. It's okay, but I don't like the fonts. So let's see what material does. Material is, in my humble opinion, much more interesting because not only I have a weak spot for these shadowed panels, but I think that material is much more interesting. Now we also have material dark, and we have material nova. So nova is almost the same as a main material, but it has different background color. So going back here, let's see what this looks like. Okay, so this looks like the same. We have two shadowed panels. We have grid styled in the material nova colors, and we have, well, the tree is styled as well. As usually is with Telerik, Telerik provides us with editing facilities. So here we can add subtask. We can edit any of the tasks, and we can delete. So we cannot delete. Well, we actually can delete. So if we delete this, it will delete the task with all its subtasks. Now, in the markup, I can suppress the delete if I wanted to. If the task has subtasks, so logically that you have to deal with subtasks first and then delete the task. But I am suppressing this, so just on purpose, I'm making only top level tasks, being able to add subtasks to it. And that is done, well, it's done primarily for demo purposes because I think that my gun control looks better if it only has one line of succession among tasks. Quick look at the structure of the Blazor project as it is. We already seen the structure of WPF. So Blazor project has been created using the template from .NET 8, and it actually not only .NET 8 but the template provided by this new version of Visual Studio. So that gives us Microsoft keeps simplifying templates. With every next incarnation, you'll have less folders, you'll have less preset files, etc., etc. So here we have just we have two folders. So this is the www folder, and which has JavaScript stuff, and this is the components, and that has all componentry and everything that we have to write in order to get something on screen. So I'm using regular layout that I like. So the components, rather components are separated into pages, which are outer components. They don't have much in terms of business functionality, but they hold other components in place, and they provide the layout setup. Now, inside the pages, there are presenters. Presenters, I think it's logical to have them to hold a single control. So one presenter, in my case, holds gun control. The other presenter holds project grid, and the third task tree. So I have three presenters. Let's take a quick look what presenters look like in this implementation. Task tree has, of course, the whole markup, the rather code for the tree. It's not that big. It has notification, tree list, and that's about it. Now, the code behind is almost non-existent, so there virtually is no code behind. This code is executed on the page first rendering. It gets the tasks to populate. It's a great part. What else? It calls the base class, and it subscribes to some events. Now, on data refresh, when, for example, we pick a project and we need to refresh the tasks, it does the same thing. It gets the tasks and then it waits for state change. And this is the last one, is like a technical little piece. It pops up the dial. The gun control has even less code behind. Well, let's open this just for a heck. It's just a control. So the code behind again has on render, on initialize async, it gets the tasks, and that's about it. Now, every single presentation component has, let me put it this way, they all have one thing in common, and that thing in common is this: they inject a view model piece, a view model service, or view model to be just simple. So view model sits in the dependency injection container, and it's available for injection by all presentation modules. And view model is playing very active part in the life of every presentation component. As a matter of fact, it does everything for it. So whatever we see here is done using view model. The reason that there is no code behind is all the code, all the logic is in view model, and it's used here through that injected component. Now, view model is part of the domain. So both Telerik and WPF presentations are sitting on the same domain, and they are using not exactly the same but similar view model. View model is a little class structure here, and it has a common code, and it has a code which is specific for each presentation technology. So we have view model for Blazor and view model for WPF. Another component that is very important and it's used by both presentation projects is a processor. Processor is responsible for all database communication and essentially everything else that doesn't have anything to do with specifically with visual presentation. So that's the responsibility of the view model. View model base class is not that big, and it contains just four regions. So it's a project task relation code. It's the events, static collections, and constructor. So the code is, I don't even see reason to explain what the code does because it's quite obvious. So this part of the code, these are two cascading dependency injection classes. So the base class creates and holds all these cascading classes, and the derived class can use them. So derived class has a static in its possession, and it uses one of the cascading dependency injection classes that are defined in the base class. And then again, what does Telerik, the Blazor Telerik component have? It has constructor. Okay, not interesting. And it also has CRUD functionality. So what we see in CRUD: create, update, delete. As I mentioned, processor is responsible for database operations. So here we see on create, we call processor to create entity and record it into the database, and then we refresh all related data so the page gets refreshed and not become stale. So it always abreast with the data in a database. I think it's time to wrap up. The conclusion of all this presentation and how I structure things would be keep it simple. That's my motto. Everything is minimalistic and simple. I do not put anything just for the heck of it. I'm trying to keep things just the way they are and not second guess existing structure as long as it works properly. If it doesn't work properly, then another simple solution needs to be added. So in this case, if we touch upon CSS aspect quickly, I didn't add any CSS of my own creation. The first one is added by a template, right? So once I incorporate Telerik controls, it adds the second one. At this point, application will not work. I'm not gonna like comment out the theme and show you how ugly it becomes because it's not really that pleasant. So I add the Telerik theme, which is the big CSS set, and then of course I add a little JavaScript code to switch themes, which I already demonstrated. So this theme is a Bootstrap um, default, and then we can flip through other themes and see what they look like and keep the one that we like the best. But the main principle is do not add any more CSS. All we get if we add some wild CSS sets, wild styles and stuff, and just hope that they will be working well together, they will not. There will be collisions between CSS libraries. Also, the browser, of course, using the concept that is known as specificity. And when there are colliding styles, it decides which style is more suitable for each visual control. And sometimes it decides really ugly, in an ugly way that produce ugly result. So the specificity decisions should be also kept to the minimum. The CSS isolation is a good thing, but it's again, it's second guessing. We have a existing CSS, and then we start adding the other CSS sets, hoping that through the concept of isolation, we will get each visual page work differently and to our benefit. It may or may not be successful. What it will add is time. That's definitely that's a disadvantage that we shall get. And the second and last for this presentation important principle that I would want to underscore here is the simplicity and the completeness of the view model. So here we look at the view model, and this view model should be sufficient enough to maintain all the states of the visuals in our presentation. So visuals should only change their visual aspects by mutation of data in the view model. That, among other things, let's see if we can get back to the diagram. So I put this little piece here for the reason. This is end-to-end tester. The end-to-end tester is the console application that will run, and it will go through all permutations of view model data states, all mutations that we can come up with, and all mutations that our visuals induce in view model. And if a tester which asserts the results of the mutation in a view model data produces no errors, that usually means that there is the visual application will be 100% correct, and we don't need army of human testers that are poking into all possible controls and just try to find where the visuals are inconsistent. The view model test, end-to-end test, should be sufficient enough to do that. An application can be completely self-testable, and when there is this facility that can run against view model and make sure that no change produced breakage in the other changes, then everybody sleep well, especially management, who know that developers didn't break anything overnight, and they can go to their management and report that software is in perfect condition. So at that, I will wrap it up. Thank you very much for watching, everybody, and until next time.